Good afternoon, ladies and gentlemen. Now, today I'm going to share with you a little thing about this aspect of math. It's called geometry. What does geo mean? Earth. Geography, earth. So it's earth measurements. That's all it is. Okay? Simple. Now, I want you to just remember this one sentence. Say after me. Right. Across. An X. And a Z. Do you believe that that is all of geometry without circles? Right across an X and a Z without actually dealing with circles. Guess what? Right angles, acute angles, complementary, reflex, obtuse, straight angles, supplementary angles. Adjacent angles, X angles, vertically opposite, equal, and Z angles. Now, look at this. What do you notice I just made? I made a Z. Look at this Z. See that? Alternate interior angles. Look at this Z also. See how this Z, called Z in English. That's also alternate interior angles. Look at this. Do you notice that these two angles here, you know, they share the same, they share the same side underneath the two parallel lines? Guess what? They're allies, because so it's allied interior angles, 180 degrees. All right? And what do you notice here? I can go right ahead, and if I go here, look at this. If I go here, right, and I go here, let's say I could take up this, I could put it right there, couldn't I? Guess what happened? Corresponding angles. Because you can just take it up and it will just fit right there. Now, right angle, acute angle, less than 90 degrees. Complementary, it's complementary, it adds up to 90. It's reflex, right? Look here. The reflex is the bigger one. See it? 360. This one and this one, they add up to 360. So it's reflex. So when you hear somebody talking about flexing, you know, okay? Straight angle. Why is it called a straight angle? Let's say I'm standing here. Why is it 180 degrees? I'm standing here. I'm at 0. What do you notice? I just moved 90 degrees. I just move another 90 degrees. 180 when you add them together. So you see, you just went this way, that's 90, and you come add this way, that's 180, but I don't have to show that. Alright? Now, let's just quickly show you how geometry all started. Why was it important? Black people started it in Africa. You know what? Because when the monsoon rain, the rain came down on the Nile, and guess what happened? My piece of land was in the Nile bed, right? I was adjacent to you. But guess what? I have to run away, because guess what? It'll go wash away everything. But guess what? When it brought all the fertile soil back down, I needed to find where my plot of land was. And so, there's geometry. This is how it started. What is that? A point or a dot. If I have several, alright, so that's a point, right? Let's say I have several points, and I just brought them all together. See? I made what?
Straight line.
No, I made a line segment. S-E-G-M-E-N-T. Why is it a segment?
Stops.
Because it can be M-E-A-S-U-R-E. So segment, I can measure this. See it? It starts and it ends. See it? Now, it starts and it ends. I'm going to go a little further. And I put a weight in there. I start here, and I just go all the way down there. I just made what is called a ray, right? Guess what? So I had a ray there. I'm just going to put another ray here, okay? Guess what I did? I just made a straight angle or a straight line. Guess what happened? I'm going to take a ray and just add another ray. Guess what I just did? I just started making angles. So this is the sort of build-up we need when we teach math to our children. That guess what? From one, you know, it's consecutive, so they have a point of reference and know exactly what is what they're dealing with. So a point, then we have a lot of points, and we just squish them together, line segment. We just go in one direction. We have one end point, right? And it goes in that direction. It's a ray. We take two rays, put them side by side. We get a special kind of angle. We can take a ray and make any kind of angles, right? And then, of course, guess what we did? When we take the angle and we just close it, right? We have what is called triangle. The next time we'll probably look. And guess what we have here? We can find two things here. We can find area and we can find perimeter, right? What's an area? An area simply, when I used to go to school and teach, I go, oh, I don't have so much problem. Guess what an area is? You have to know what an area really is? It's just a length times another length, not more. The area of a circle is a length times another length. And I'm going to sit down after this. Let me just show you, let me just give you the real thing behind it. Let me show you how it's a length times. If I had this triangle, right? Okay? A lot of you know the formula as what? Half base times height. What did I say it was? A length times another length. If you have, say, a rectangle or a square, a length times another length, right? I told you that if you have a circle, it's a length times another length, don't? But then, you know, you have to tweak it a little bit. Let's tweak it. What is half of this? Because, hey, it just depends, you know. And a lot of people never told you this, that it's just a base is what it sits on. So I can take this and turn it round and sit down on it, so I can use this as a base too. I can take that and just split it again and make it as a base. So your teachers were just making you feel that this thing was a whole heap of, well, it's easy. Isn't that a length times another length? Alright, most of you tell me that what? Length times width. Isn't that a length times another length? But see, you tweak it. I'm going to have to tweak a little one. The area of a circle is equal to pi r squared. What is that? The radius is from the middle to any point on the way in there. Isn't that a length? Didn't you take two lengths and wait in there? Ask me, where did this come from? Anybody have any idea where does pi come from? Pi r squared? Let me see another. Anybody who can tell me. You know it's 3.14 or something. It's 22 over 7. But where did it come from?
From an idea?
No, you know where it came from? This is where it came from. Let's say that this is what? A circle, don't? How much minutes over?
You got 2 minutes. You good?
You give me 2 more minutes?
Yeah.
Alright, what do you notice here? This is a circle, don't? What do you notice here? It's a circle. There is a relationship with all circles. And the relationship is right here. Pi actually is the diameter. 3. If I took a piece of string, let me your shoes lace, and decided to the real visual effect. If I decided from here to here is the diameter, right? Guess what happened? If I did this, I get 1, 2, 3, and a little piece. So that's the relationship of pi. That is why you will get 3 diagonals and that one little piece, that 0.14 with all circles. But it just depends on what is the length of the diameter. Right? Kind of make it a little easier. Any questions? Hey, you know something?
I see it.
Hold it down, blood.